Okay, in this video we are looking at gas laws practice number 2. And the first problem in this practice says a helium balloon at sea level has volume of 2.1 liters at 0.998 atm and 30 degrees Celsius. If it is released and rises to an elevation, at what pressure is 0.900 atm and temperature is 28 degrees Celsius, what will be its new volume? So this problem has a lot of information in it, and so we need to start by labeling our variables so we can determine which gas law we need to use here. So let's start at the beginning. Has a volume of 2.1 liters. So that's a volume, so we're going to put that as our initial volume at 0.998 atm, so that's an initial pressure, and 36 degrees Celsius, so there's our initial temperature. It's released, rises to an elevation at which the pressure is 0.9 atm, so a new pressure, P2, and the temperature is 28 degrees Celsius, so a new temperature, T2. And then it says what will be its new volume. So we're asked to find V2. So V2 equals question mark. So in this problem, we're relating volume, pressure, and temperature, and all three of these variables are changing. So when we write out our gas law, PV over NT, we need 3 out of these 4 variables. We need pressure, volume, and temperature. And so this is the combined gas law, P1 times V1 over T1 equals P2 times V2 over T2. So we need to use this combined gas law and plug in all of our different variables in this problem. So before we start plugging things in, let's check our units. We know we need both of our pressures to have the same units. Our P1's in atm and our P2 is also in atm, so we're good on pressure. Okay, so let's check volume. Volume, our V1's in liters, and we're looking for our second volume, so that means that our V2 is going to come out in liters. We're going to get some number of liters as V2. Okay, and then our temperature, our T1 is 36 degrees Celsius and our T2 is 28 degrees Celsius. But we know that to use a gas law, we need our temperature in Kelvin. So T1 and T2, I'm going to go ahead and convert those to Kelvin. So 36 plus 273 gives me 309 Kelvin for T1. Okay, and then 28 plus 273 gives me 301 Kelvin for T2. So now we have our temperature in Kelvin, which is what we need. So let's substitute in some numbers. P1 is 0.998 atm times V1, 2.1 liters, over T1, which is 309 Kelvin, equals P2, 0.9 atm, times V2, which we don't know, so we're going to put an X, over T2, which is 301 Kelvin. So this is just a lot of numbers to substitute in. It's not really any harder, just more numbers. So now we need to cross multiply and do some algebra. I'm going to get rid of my units when I cross multiply and just hold on to those numbers. So let's see, 0.998 times 2.1 times 301 will equal 309 times 0.9 times x. Alright, so I'm going to go ahead and multiply these numbers together to combine some like terms. 0.998 times 2.1 times 301. And I got 630.8358. I'm going to hold on to that whole value. I don't want to end up with a rounding error. Equals 309 times 0.9, 278.1, and then I can't forget about that x. Alright, now to get x by itself, all I need to do is divide by this 278.1, and whatever I do on one side, I do have to do on the other side as well. So these cancel out, and then we're going to put x up here. X equals whatever this divided by this is. Fortunately for me, I can reselect these in my calculator instead of having to type them all in again. 630.8358 divided by 278.1 gives us 2.26837. So I'm going to round to 84. And my units here we said are going to be liters. So that's my value of V2 is that. So I'm looking for an answer that's very close to 2.268. Or 2.3 is the answer up here. So C is the correct answer. Alright, question number 2 says a 0 degrees Celsius and 1 atm sample of a gas occupies 30 milliliters. The temperature is increased to 30 degrees Celsius and the entire sample is transferred to a 20 milliliter container. What will the new pressure inside the container be? So I'm going to start at the end labeling my variables. New pressure, that means I'm looking for a P2 value. P2 equals some number. Alright, at 0 degrees Celsius and 1 atm, the sample occupies 30 milliliters, so these must be all my initial values. 0 Celsius would be a T1 value, 1 atm would be pressure, a P1 value, and 30 milliliters would be V1. The temperature increases to 30 degrees Celsius, so there's my second temperature. And the entire gas sample is transferred to a 20 milliliter container. And we know that a gas will expand to fill the container that it's placed in. So that is my final volume, my V2 value there. Okay, so now that we have all of our variables labeled, we need to check the units on all of our variables. We're definitely going to use the combined gas law here. So P1 times V1 over T1 equals P2 V2 over T2. But we need to check all of the units on our values. Let's first check pressure. We have ATMs, and so our new pressure that we're finding will also be in ATMs. Volume, we have milliliters on one side and milliliters on the other side, so those are fine. And temperature, we have degrees Celsius and degrees Celsius, and we know that to use a gas law, we need our temperatures in Kelvin. So I'm going to convert my T1 and my T2 values to Kelvin by adding 273. 0 plus 273 will give me 273 Kelvin. And 30 plus 273 will give me 303 Kelvin. So now that we've checked all our units, all we need to do is substitute in some numbers. Let's see, P1 is 1 ATM. 1 ATM times V1 is 30 milliliters over T1, which we converted to Kelvin, so it's 273 Kelvin, equals P2, which we're looking for, so we don't know that yet. I'm going to put in X times V2. V2 is 20 milliliters over T2, which is 303 Kelvin. So here we're going to have to cross multiply, and I'm going to leave off my units when I rewrite all these values. So 1 times 30, that's 30, times 303, I'll put that 1 there just so we don't get confused, equals 273 times 20 times X. We don't want to forget that X. Okay, so let's combine some terms. Put this in our calculator. 30 times 1 times 303 gives us 9090 equals 233 times 20, 4660X. Now we just need to isolate X, and to do that we'll divide by 4660, and we'll do that on both sides of our equation. So left over we get X equals 9090 divided by 4660, which gives us 1.95. And we know that our units on our pressure value are going to be ATMs. So this is our value for P2, and we're just going to look for an answer choice that's very similar. 1.95 is very, very close to 2 ATMs. 2.0. If we were to round to a whole number, it would round to 2.0. So C is the correct answer. Okay, our final question. A sample of air in a syringe exerts a pressure of 1.02 atm at a temperature of 22 degrees Celsius. So this looks like an initial pressure and an initial temperature. The syringe is placed in boiling water at 100 degrees Celsius. And the pressure is increased to 1.23 atms by pushing the plunger in, which reduces the volume to 0.224 milliliters. What was the original volume? Okay, so the problem is asking us for our V1 value. So, we have some other pieces of information that we need to work through. First of all, the pressure is increased to 1.23 atm, so that must be our second pressure, our P2 value. And reduces the volume to 0.224 milliliters, so that must be our second volume, our V2 value. And we're asked specifically for the original volume. Alright, and then the syringe is placed in boiling water at 100 degrees Celsius. So we are to assume that when we put that syringe in the 100 degrees Celsius water, the temperature is increased up to 100 degrees Celsius. So this would be our T2 value. So this problem has a lot of information. Go through and label the easy things first, and then that may help you figure out the final pieces of information. Okay, let's check our units. As always, our P1 value is in atms, and so is our P2, so our pressures look good. Our volume, our V2 value, is given in milliliters, so our original volume is going to come out in milliliters. So our V1, whatever we get, is going to be some number of milliliters. And then lastly, we need to check our temperatures, which of course are given in Celsius, and we know that we need Kelvin. So we're going to go ahead and convert our T1 and our T2 values to Kelvin. 22 plus 273 gives us 295. And then 100 plus 273 gives 373 Kelvin. And once again, we are going to use the combined gas law. PV over T, 111, equals PV over T with 222. There we go, our combined gas law. So let's go ahead and do some substituting. Right, let's see. So P1 is 1.02 atm times V1, which we don't know V1, so we're going to substitute an X, over T1, which is 295 Kelvin, equals P2, let's see, our P2 is 1.23 atm, times V2, which we know is 0.224 milliliters, over T2, which is 373 Kelvin. Alright, we have our problem set up. Now we just need to cross multiply. So we have 1.02, which I'm going to leave off my units, 1.02 times 373, and still times X, equals 295 times 1.23 times 0.224. Alright, let's combine some of these terms here. 1.02 times 373 gives me 380.46 times X equals 295 times 1.23 times 0.224. which gives me 81.2784. Now to isolate X, I just need to divide by 380.46, and I do that same thing on both sides. These cancel, and we're left with X equals 81, whatever that number is, divided by 380.46. 0.2136, and our units on our answer are going to be milliliters. Okay, looking up at our answer choices, we're trying to find our V1 one value, that's equal to V1, that's very close to this answer, 0.2136. 0.214 is very close to that, so B is our correct answer. Alright, our next problem here says a cold 2-liter bottle of soda contains 46.0 milliliters of gas confined at a pressure of 1.3 atm at a temperature of 5.0 Celsius. If the bottle is dropped into a lake and sinks to a depth where the pressure is 2.85 atm and the temperature is 2.09 Celsius, what will be the volume of the gas in the bottle? Okay, so in this problem we have some extra information that is kind of confusing that we don't need. So let's start with what we're asked for. It says what will be the volume? So we're looking for our V2 value, our new volume. V2 equals something. But we need to decide which of these volumes is our initial volume. Well, even though the bottle is 2 liters large, it only contains 46 milliliters of gas. And so this is our V1 value, not the 2-liter bottle. A 2-liter bottle can hold up to 2 liters of something, but it doesn't have to be full. And so this 2-liter bottle is kind of extraneous information. This is our V1 value. This 2 liters is kind of confusing, but it's just telling you the type of bottle. It's not actually relevant to the problem here. Okay, so the 46 milliliters of gas is confined at a pressure of 1.3 atm, so that is our P1 value, and a temperature of 5 degrees Celsius. So there is our T1 value, our T1. Bottle dropped in the lake, sinks to depth where the new pressure, P2, is 2.85, and the new temperature is 2.09 degrees Celsius. So there's our T2. What will be the volume? We already determined that. So this is another combined gas law problem. So we need to go through P1 V1 over T1 equals P2 V2 over T2, and we need to check our units. So our pressures, we have ATMs and ATMs, so our pressure looks good. Our volume, we have milliliters, so our new volume is also going to be in milliliters. Looks good. And our temperature, both of our values are once again in Celsius, and we know that we need them in Kelvin. So T1, T2, let's go ahead and convert those values to Kelvin. So T1, 5 plus 273 is 278 Kelvin. T2, 273 plus 2.09 is going to be 275.09 Kelvin. So now we have our temperatures converted to Kelvin, and temperature looks good as well. All we need to do now is plug in some numbers. Let's see. P1 is 1.3 atm times V1, which is 46 milliliters, over T1, which is 278 Kelvin, equals P2, 2.85 atm, times V2, which we don't know, so we're actually going to put in X, over T2, 275.09 Kelvin. Okay, now we need to cross multiply. So we're going to do 1.3 times 46 times 275.09 equals 278 times 2.85, put that in parentheses, times X. Let's go ahead and combine some terms here. Let's do 1.3 times 46 times 275.09, 16450.382 equals 278 times 2.85, 792.3 times X. We don't want to forget that X. Alright, now the last step to isolate X is to divide by 7 92.3, and we'll do that on both sides. These cancel. We end up with x equals this previous number divided by this previous number. 20.76, and my units should be milliliters, and of course that is my value of V2. So now we just need to look at our multiple choice answers and find one that is close to 20.76. 20.8 is very close, it's just rounded differently. So A is our correct answer.